Morning. My name is Long, and I will go over my team first homework assignment, which is coding the rotating donut. For this homework, our team choose the cube as a shape that we will animate and make it rotate on the terminal. And in part one of this video, I will show you the code performance and explaining what I did during this project. So let me show that. Right, as you can see right here in the terminal, you can see the cube that we code spinning and rotating. So in this project, my main contribution is to help the code render a rotating 3D wireframe of the cube in the console using the ASC2 character, which is based on what the code you give us in the spinning donut, which is just basically the character brightness right here. And I also made the cube rotate and applied like a perspective projection and continuously update the display to create an animation as you can see on the terminal. And then let me also show you what the code look like for donut, which is this right here. And yep, this is based on what you give us in the textbook, and it's we use that as our foundation for our spinning cube. And then let's go to part two, where I will go over the code I wrote in this homework, which is the yellow highlighted code over here. Alrighty, give me a second. So if you can look at the first part of the code, which is the cube vertical here, it will basically define the 3D coordinate of the cube vertical, which is each of the two faces of, well, technically 8 vertical, there's 8 faces to the cube. And the numeral, the number inside, represent the x, y, and z of each of the point in the square, basically. So because the cube 8 vertical, 4 for the back face and 4 for the front face, each of this will represent each point of the front and back face. And then moving on to the edge connecting vertical, this will define the edge of the cube as pair of indicate referencing to the vertical array, which is above right here. Each pair will have a start and an end representing the line segment connecting the two faces, which is the front face and back face, the edge connecting, which is basically drawing the line from the front end to the back end. And then let's move to the rendering, the loop. This while true loop, oh wait, where's my mouse? This while true loop right here, the purpose of this loop will be making like an infinite loop that continuously render the frame. The screen will represent a array of character that like frame buffer for the 2D rendering with the dimension of width and height that we initialize up here. And then the Z buffer will be an array to track the depth, the Z value of each pixel, which can be used for depth testing to ensure the correct visibility. After that, I initialize the screen and the Z buffer. This first part, this for loop right here, will fill the screen with empty space and initialize the Z buffer to the lowest possible depth. And then moving on, this next for loop right here will iterate over each edge. Will the rotate and project right there will rotate the 3D vertical and project them into a 2D screen coordinate. And then the draw line will draw a line between the two 2D point P1 and P2 on the screen using the Z buffer for depth testing. After that, I will print the frame with the system outprint, the 033, whatever. It will clear the console and move the cursor to the top left corner using the ANSI escape code. And then it would continue print a loop to render the screen buffer line by line. Moving on to the A, B, and press sleep right here. The purpose of this tree will be just basically incrementally update the rotation angle A and B, which is the y-axis and the x-axis, to animate the cube rotation. This will pause for like 50 milliseconds to control the frame rate. So let's say if I want the frame to go faster, I can reduce the number to like 20 or 30, but I keep it 50 to keep it, not moving too fast. Moving on, the private static double rotation project. This is the function to rotate and project a 3D vertex into the 2D screen coordinate. And then the double X and Z1 right here. This will apply the rotation matrix around the y-axis. The math I use from the y-axis, x-axis, or whatever is based on the code that you've given us in the book. And that similar case to the x-axis over here, where we'll use the math cosine and sine cosine to calculate the rotation of the x-axis. And finally, I wrote a code for the projection to 2D. The OOZ, double OOZ right here will basically inverse the depth of the Z2 and K2 for perspective projection. And then for the XP and YP, it will convert the 3D coordinate into 2D screen position. Adjust it to the center of the screen by using the math solution, math, math equation right here, which is basically width divided by 2 or height divided by 2, depending on if you're looking at the x-axis or y-axis. But yeah, that's basically all the code I've written for this first homework. All the red highlight is the code from my teammate, and the blue is the one I mainly taken from the notebook. Thank you very much.